Hello everyone, welcome back to our channel. So today we are going to solve this lead code question number 130, surrounded regions. So let's go through the problem statement quickly, and then we are going to jump on to the algo and discuss how we are going to solve this. So let's read out the problem statement. So we are given an m by n matrix with the letters containing only x and o. And what we have to do is we have to capture the regions which are surrounded. And we are given like different sort of definitions for connections for region and string. So a cell is meant to be connected if it is connected horizontally or vertically, and then we have given the definition of region and surrounded. So as an end goal, we have to capture the regions which are surrounded, and it is also given that to capture a surrounded region, we have to replace all the zeros with x, and we have to do it in place. So we have to alter the existing given matrix, and we have to do changes in that only. So to capture a region, you have to replace all zeros with x within the original mode. Okay, let's quickly discuss like what definitions are given. Okay, so first of all, we are given a definition connection. So connection, how different cells would be connected is they can be connected horizontally, which means left or right, and then they can either be connected vertically also, up and down. So these are the four directions that we can go, and we can see if a connection is there. And then for region, and we have to keep in mind also that diagonally the cells cannot be connected, so we have to ignore all the diagonal connections. Then we are given a definition of region. So in region, all the connected zero cells, so all the zero cells which are connected, how they would be connected via horizontally or vertically. So all the zero cells which are connected among themselves is called a region. And then surrounded. So surrounded, we are given that all the zero regions which are not having any boundary, zero element. So by surrounded, so over here in this example we can see that we have two regions. One would be this region, and another one would be this region. So these are the two regions. Why? Because these three elements are connected with each other either horizontally or vertically. So if we go from this particular element, we go to the right side, we land on this element, and then if we go to the down side from this particular zero element, from this one, then we land on this element. So now when we go in all the four directions, we would be getting x. So in all the three directions, so one, we go down, and then we go towards left, we again encounter x, and then we go towards the right, we again encounter x, and on top we are coming from this particular element, it's already zero. So this is one of the region. And then another region would be all the zero elements. So this would again be a region, because this is diagonally connected to this but not horizontally or vertically. So there are two regions in the given problem example. So these are the two regions, and surrounded, what they mean is uh, all the zero regions which are not having any boundary element. So we see this particular region which we have here, right? This particular region. So this region does not has any boundary elements, which means this region is surrounded. So this region is surrounded. And then this particular region down below, this is not surrounded. So what we have to do is, as per the problem statement which is given to us, we have to capture a surrounded region by replacing all zeros with x. So eventually what we have to do is, so this is a surrounded region, and all the zeros which are present in this region, we have to replace them with x. So let's discuss how we are going to solve this problem. So let's take this example where we are having, as discussed, we are given this as a region and this as a region. We are seeing these two regions in this problem statement. Now how we are going to approach this problem is, we are going to traverse the boundary rows and the boundary columns. So so this is the row which we are going to traverse, and this is the column which we are going to traverse, and then this row we are going to traverse, and then this column we are going to traverse. Why we are traversing the boundary elements? Because it is given, if a region is having boundary zero element, then only it is not considered as surrounded. Otherwise, if it is not having any boundary zero element, then it would be considered as surrounded. So first of all, what we are going to do is, we are going to traverse all the boundary rows and boundary columns. So these are the 4 rows and columns which we are going to traverse. So these 2 rows and 2 columns we are going to traverse, and we are going to what we are going to do is, we are going to mark all the elements which are not surrounded. By not surrounded I mean, so let's say, like, we go on from we traverse this particular row, and then we encounter that there is a zero element, but zero element is not adjacently connected, either horizontally or vertically connected to any of the zero elements. Then what we are going to do is, we are going to mark this as not a surrounded region. So we are going to mark this as y. So why we are marking this as y? Just to keep this element as visited. So so that this comes under a not surrounded region. So what we are going to do is, we are going to mark this element as y, just to say, okay, that this is not going to be captured. So this is the region which is not going to be captured. So the transformed matrix from here would be, all the zeros which are surrounded, they will remain as is, but all the regions or zeros which are having any of the boundary elements, they will be marked as y. So over here this element is marked as y, and then finally what we are going to do is, we are going to traverse this entire matrix, and we are going to mark all the zeros which are present over here as x, because we are going to capture this region, but this region won't be captured, so we are going to again mark this as 0. So the final matrix for this problem would be, all the zeros are marked as x, these all zeros are marked as x, and then this 0 will remain as. Let's quickly see the algo, how we are going to solve this step by step. So first of all, we are going to traverse all the boundary rows as mentioned. So this is one of the rows which we are going to traverse, and then this is one of the rows which we are going to traverse all the boundary rows, and then traverse all the boundary columns. So for columns, this is the column that we are going to traverse, and then this is the column that we are going to traverse. These 2 columns we are going to traverse. After traversing these 2 columns, we have to do a DFS traversal. So this is a classic problem of DFS. So we have to do a DFS traversal and mark all the adjacent elements from the boundary element to a different character. So over here uh, we would be encountering that, okay, we encounter the 0. Are there any adjacent element? If there are any adjacent element, we are going to mark all of them as a different character y. But since only this is the element on the boundary and not connected adjacently to any of the zeros, then we are going to mark this as y. So we are going to mark this as different character y. Then what we have to do is we have to traverse the entire matrix again and then mark y as 0 and 0 as x, because we are going to capture that region which is not surrounded. And for the DFS algorithm that we are going to run for all the boundary rows and columns, it would be, we have to check if rows or columns is out of bounds. If it is going out of bounds and the element is not 0, then we are going to return. If these conditions are not, if not satisfied, if element is not 0, or if it is if either row or column is getting out of bounds, then we are going to return from here. Otherwise we are going to continue with our existing algorithm. So what we are going to do is we are going to mark the current element as y, because this is the element which is not comes under surrounded. So this is the element which does not needs to be captured. So okay, so all the boundary elements, first of all what we are going to do is we are checking the boundary rows and columns, and then we are going to check if the element is 0, then only we are going to continue. Once we encounter, okay, it's a boundary element and it's a 0 element, and then we are going to mark this as y, and all the adjacent elements whatever are there from this boundary element, we are going to make a recursive call. We are going to make a recursive call in all the 4 directions. So what 4 directions would be? It can either be row plus 1, row minus 1, column plus 1, column minus 1, up, down, left or right. So either of these directions we are going to traverse all the elements and see if any of the element is marked as if any of the element is 0, then we are going to mark that element as also y. So that is how we are going to solve this. Let's quickly jump on to writing the code as per the algo, and let's see how we are solving this. Okay, first of all we are given a board of characters. What we are going to do is we are going to firstly see how many rows are there. Rows would be board dot length, then columns would be board of 0 dot length. And then what we are going to do is we are going to traverse the boundary rows. So for traversing the boundary rows, we have to write a loop for row is equal to 0, then row less than rows, row plus plus. We are going to check So what we are doing over here is we are traversing over the rows, and we have a fixed column which is 0. So we are going over the rows, but we are going over the fixed column which is the first column. So we are traversing here the first column, and we are going to call a DFS method which we will be writing the next step. So here we are traversing the first column, and then we would be traversing the last column. Node, rows, columns, row, columns, this one. So in this loop, what we have done is we are iterating over the set of rows. We are iterating over the first column, and we are iterating over the last column. So these are the two columns that we have traversed now. Now let's jump on to the two rows, which are the boundary rows which we are going to traverse. And column. So here we are going to fix our row, and the column would be wing. Now we have to go over the first row and variable column. We are going to check if that particular element is 0, then only we are going to continue DFS. So we are done with traversing the first row. Now let's traverse the last row and see if we have any 0 elements. Then we are going to do DFS. Okay, so after doing DFS over the boundary elements, what we are going to do is, after coming out of the DFS, we are going to traverse the entire matrix again and mark the respective 0 elements as y and all the zeros as x. So let's do that, and then we will write the code for DFS. For int row is equal to 0, row less than rows, row plus plus. Then we are going to iterate over columns, and inside this what we are going to check is if the current element is equal to y. If the current element is y, then this region we don't have to capture. Then we have to replace this element as the original element 0. Then otherwise what we are going to do is if the board row with the current element is coming as 0 already, which means this region needs to be captured. On row okay, so now we are done with this, and we do not have to return anything because we would be replacing everything in place. Now let's quickly write an algorithm for DFS also. Rows, columns, current row, current column. Now first thing what we are going to check in DFS is we are going to check if the current row or column is out of bounds or if the current element is not 0. If any of these condition is met, then we are going to return from here itself. So boundary condition would be if row is less than 0 or if row is less than 0 or column is less than 0 or column is greater than or equal to columns, the maximum columns, or row is greater than equal to rows, or the current element would be board of row and column is not equal to 0. If it is not equal to 0, if any of this condition is met, we are going to return from here. Then if we encounter we are going to continue from here, what we are going to do is we are going to mark this current element with a different element so that we know that this region we do not have to capture. And then once we mark this, we are going to make a recursive call in all the four directions. So what we are going to do is DFS board rows columns, then row plus 1 with existing column, DFS board rows columns, then row -1 with existing column, likewise for columns. Mode rows columns, row column +1, then DFS mode rows columns, row column -1. I think that's pretty much it. So first of all, let's quickly go through. We are going through the boundary elements. So we are going through the boundary elements where we are going through the first column, we are going through the last column, and then we are going to go through the first row along with the last row. So after iterating, we are going to see if any of the elements is marked as Y, which means this is the region that we do not want to capture. So we are going to mark all the elements as original element 0, and then if any of the elements is existingly 0, then we are going to mark it as X, which means we are capturing that particular region. And then inside the DFS, we are checking the boundary conditions, and then we are marking that element so that it won't be captured. And then we are calling DFS in all the 4 directions, horizontally and vertically. Okay, let's quickly try to run this. Okay, so we are having some test case failure. Let's see. Okay, so there was a typo where we do not have to consider 0, it is X and O. So we have made the corrections. So now this is O. Now let's try to run this given 2 test cases. Okay, so the test cases are running. Let's try to submit this. Okay, so all the test cases have passed. Okay, thank you so much for tuning into the channel. That's it for today. See you again in the next video. Thank you so much.